Okay, first thing we do is open the QuPath and drag an image into the window. Then we're gonna zoom in to whatever area we want to detect cells in and make a box or whatever annotation. Then we'll go to Analyze, Cell Detection, and you can adjust these settings if you'd like, or just use the defaults. The cell expansion is an important one, and it defaults to 5 microns. So that's pretty quick, and looks like it did a pretty okay job. Although you can see that this cell, for instance, is 2 cells, and you know, it had maybe some problems here and there. Like, I don't think that one is a cell. You can look at just the cell nuclei, which helps kind of clean things up by right-clicking and then doing nuclei only. And you see that a lot of these nuclei are not very regular looking. So, you know, this default detection method in QuPath is actually based on the Watershed segmentation, and it doesn't use machine learning, so it's not really the greatest, but it is fast, and so it does a job. Okay, now that we've done Watershed segmentation, the second method that we're going to try is the StarDist segmentation. So for that, we need to install the StarDist plugin, and there's a process to that. So navigate to the StarDist docs page, and you'll see a couple of useful links. The first goes to the actual extension file, which we'll need to download. Go to Releases. And then if you have QuPath version 0.5, you'll just download this jar file. I've got 0.6 installed, and it's not an official release yet, so also plugin not listed here. But we can navigate to this forum, and they have a zip file on there that we can download. So we'll go Downloads, Save, and then we will also download the StarDist model weights, and that's going to be at that second link. We'll need the HE heavy augment. Okay. And now we should be good to go. So to install the extension, we need to just drag and drop it into our file here. And I already have it in there. So it should be installed, restart QuPath, and then you can go to Extensions, StarDist, and then we want the bright field cell detection script. So this is going to allow us to run the cell detection, but we have to change where the model path is right here. So def model path, and we want to redirect it to our actual model file, which is located here. So we'll just paste that in. And then also I found that, at least with my version, it does not like this pre-processing bit, which is sad, but a fact of life. So now we're going to run this. And you can see that it has detected the cells, and it actually looks like it's done a better job than the Watershed segmentation. It definitely looks more cell-like. The edges are a lot smoother, which is nice. So yeah, it's done a nice job. So if you wanted to save that script, then you could save it in the script editor and just save it as a Groovy file, so in a place that you can easily find it, so that you don't have to copy paste the path in to the model every single time. And that is how you would install and use the StarDist model. Now, the last cell detection method that we're going to be using is InstanCeg, and I've found that it really works great on H&E images. So let's go ahead and do that. So it's in the version 0.6, so if you don't have that version, you want to download that. You go to Extensions and Deep Java Library, Manage DJL Engines. We want to make sure that we check and download these engines. Okay, and because they're green, they're both available, which is great. I forget which one is required by InstanCeg, but I want to say it's the PyTorch one. So if you can't install one of the two on your computer, that can happen, so that would be sad. But in our case, it worked out, which is great. So we'll exit out of that and then go back to Extensions and do InstanCeg, run InstanCeg. Check online? Sure.